Hi everyone, welcome to the session. So here we will discuss some questions of the haloalkanes. Let's see one by one few questions how to solve these. The first question is, which of the following is an example of vis dihalide? Okay, so vis dihalide means vicinal dihalide, right? Vicinal. So the idea of the vicinal dihalide means something, dihalide means there is a two X groups, right? And X can be your fluorine, chlorine, bromine, iodine, right? So dihalide means there will be the two halogens that will be present, and vicinal position is that the both the halogens will be present on the one by one, right? Suppose this is your carbon 1 and that's your carbon 2. So if the halogens are present on the adjacent carbon atoms, right? If they are present on the adjacent position, right? So adjacent position you need to see here, okay? So what you expect in the first example, dichloromethane, okay? So dichloromethane, you can write what will be the chemical formula, dichloromethane, right? So C, and there will be, two hydrogens, right? And two chlorines, right? So here you can see that both the chlorines are on the same carbon, okay? So this can't be your answer. In the second case, the 1,2-dichloroethane, okay? So here if you write the 1, 2, 1 chloro, 2 chloro, okay? So 1,2-dichloroethane, rest of the positions will be occupied by the hydrogens, right? So this is your perfect answer, okay? So this is your vicinal dihalide, vicinal, right? So the answer is the B, okay? If you see the ethylene dichloride and the allyl chloride, okay? What we mean by the allyl chloride? Allyl chloride means the chlorine is attached to the next to the double bonded carbon, okay? A carbon which is next to the double bonded, that is known as the allylic position. So the allyl chloride is something this, and the ethylene chloride we will talk in the next question. What is the formula of the ethylene chloride? Okay, basically the ethylene chloride is this is the compound in which both the halogens are present on the same carbon, okay? Both the halogens are present on the same carbon, okay? So that's the ethylene dichloride, okay? Ethylene chloride, okay? Let's move to the next question. Let's see what is the next question. So if you write, let me write something here, just a minute. Yeah, so that's the ethylene dichloride that I am talking about, okay? Both the halogens are present on the same carbon, right? Ethylene dichloride. Now let's see the next, the second one, okay? Next question. The position of the bromide in the following compound, okay? So we have this particular compound and we need to just tell what is the position of the bromide, okay? So if you write this, let's see how to write it. This is your methyl group, okay? Then CH, double bond CH, okay? And then carbon, this carbon is having the bromine, right? And then methyl groups, okay? Two methyl groups are there. So one methyl group is this one and another methyl group is this one, okay? Sorry. So that's what we have to understand. So we need to just talk about the position of the bromide. Okay, so where the bromide is present. So the bromide is present on the next to the double bonded carbon atom. Okay, if you see that this is the double bond and this bromide is present on the next to the double bond carbon. Okay, so in this case you can say that what we basically say, if the any group is present on the next to the double bond carbon, then that is the allylic position, right? So this is the allylic. So allyl is the perfect choice. Okay, this allyl is the perfect choice. Let's move to the next question. Ethylidene chloride is an example of. So I talked about the ethylene chloride. What is this? Basically the three hydrogens are present on this carbon and the two, both the chloride, okay, they are present on the same carbon. So both the chloride are present on the same carbon, then they are termed as the vicinal dihalide. What is the not it's not the vicinal dihalide, it's a what, it cannot be the vinylic halide. Allylic is the next to the double bond, vinylic is the double bond. Okay, what is the vinylic position? The double bond position. Okay, double bond position is known as the vinylic position. So the answer of this is the gem dihalide. So this ethylene dichloride is an example of the gem dihalide where both the halides are present on the same carbon. Okay, let's move to the next question. Question number 4. A primary alkyl halide would prefer to undergo. So this is the primary alkyl halide, 1 degree alkyl halide, right? So you know that 1 degree alkyl halide means what we mean. 1 degree alkyl halide. Okay. So if you see the SN1 and SN2 reaction, what is the difference between these? Okay. So primary alkyl halide and tertiary alkyl halide. If you take, suppose this is the example, we have the 4 different groups that are present. So this is your alkyl halide. So this is your X, and this is hydrogen, hydrogen, and hydrogen. Okay. So primary alkyl halide. Okay. So that's this is your X. And what about the secondary or tertiary? Primary means we have the one different group. Alkyl halide is there, but we have a different group. Okay, suppose we have one group R is present over here, right? This can be there. Okay, so primary alkyl halide, always remember that primary will always prefer the SN2 pathway. Okay, whereas the tertiary prefer the SN1 pathway, right? So if you talk about the primary alkyl halide, okay, primary alkyl halide, then that will go with the SN2 mechanism, right? Primary will go the SN2 mechanism. Now next question, which of the following alkyl halide will undergo SN1 reaction? Okay, always remember SN1 will go with the tertiary halides. Okay, favorable for the what SN1 favors? SN1 favors nucleophilic substitution reaction. Okay, it always favors the tertiary, then secondary, then primary, right? So that's the case. So which one is the tertiary? Now we have the all the tertiary carbons, right? All the tertiary alkyl halides are present, but if you see these groups are different. Okay, so you just need to understand that which will easily break down. Okay, so you need to just compare the size of these halogen atoms. If you compare the fluorine, chlorine, bromine, and the iodine, okay, this is the largest in size. Okay, and largest is largest in size, then you can see that if this carbon is holding these three methyl groups, right? And there is a bulky iodide is iodine is present. Okay, this is bulky. So due to this bulkiness, the cleavage or the breaking of this bond is easily favorable. Okay, so this will easily go with the SN1 reaction. Okay, very quickly it will undergo SN1 reaction. Can you see the all the things? Yeah, bulky. So this is very bulky iodine, right? Now let's move to the next question, which is the correct IUPAC name for this particular compound. Okay, the correct IUPAC name for this particular compound. Here you can see this is the bromide. So how you can do the numbering? Either you can do the numbering by 1, 2, 3. Okay, so propane could be there, right? And this is your ethyl group. Okay, this is your ethyl group. But remember, you could think that this the option can be first. Okay, but this first is not the option, or anyone is not the option. We will what we will do here is we just need to expand this. Okay, because we have to focus on the longest carbon chain, right? So longest carbon chain, how we can get the longest carbon chain? If you write this in this manner, CH2 CH CH2 CH3, okay, like this, and then CH3. Okay, so let's do the numbering. This is your first, this is your prime 1, 2, okay, 3 and 4. That's what we need to do the naming. So at 2 position this methyl is present, so 2 methyl 1 bromobutane. Okay, the parent chain will be of the butane, right? Now let me write some more. There is a question, and that will be discussed in the next. Okay, so thanks for watching.